Now, this illustration deals with the available fault current, where it may develop or where this condition could occur. It's in accordance with 110.24a and b, and as you see, the service to the right is where the calculation label is placed, identifying what the available short circuit current would be at that equipment which the transformer produces and routes through the conductors or the wiring method to the breaker that you see there. Now, notice, let's look at the computer that's plugged into the receptacle outlet to the left. If a fault should develop at that receptacle, we would have an equipment ground routed back to that sub panel and an equipment ground routed back to the service, which would transfer this short circuit current onto that grounded conductor that you see in the panel, and it would have a grounded conductor routed back to the transformer, and that would be the fault current return path, and then you would have the fault return on the L1, L2, L3 that went to ground somewhere in the system, which in this case would be the receptacle. And then notice if you had a fault, ground fault for some reason inside the sub panel, you would have an equipment ground routed back to the service equipment, and we would transfer that fault current to the grounded bar and to the grounded conductor going back to the transformer. Now, for this to all take place, we used to say the system had to be effectively grounded. Well, designers, contractors said this is kind of a difficult thing to do if you had someone such as a plan checker, for example, wanting us to prove that everything was effectively grounded. So they said, let's provide an effective ground fault path. We can prove that. So for example, look at the illustration, the service equipment to the right. You notice the ungrounded conductors are 350 kc mil. Now, if we went to our table, 250.102C1, that is considered supply because there's no overcurrent device ahead of those conductors from the transformer to the breaker. Then, if I'm quoting it right, table 250.102C1 would require that grounded conductor to the right of the enclosure connecting to that grounded terminal bar, which is earth grounded. It would be number 2. Now say that you had, we're just saying this, a 200 amp main that was supplying power to that sub panel that was 200 amp rated, say. Then based upon 200 amp, if I'm quoting this right, it's either a number 6 or number 4 equipment ground that would be from our table 250.122. Now you notice the illustration shows that. Notice below the sub panel, we have our table 250.122. The grounded conductor routed back to the transformer, then notice we have listed for you our table 250.102C1. Now the equipment ground that is routed to the receptacle is based upon the 20 amp overcurrent device in the panel. So table 250.122 calls for a number 12 equipment ground based upon that breaker supplying power to that receptacle. Then we have an isolation type receptacle, IG, and the equipment ground from the computer bypasses the metal of the, device box, and it just bypasses the yoke of the receptacle that supports the receptacle to the box and goes directly and passes through the sub panel by 408.40 exception, not connected to any metal, but just passes through, splice through, or pull through, all the way over to the earth-grounded portion of the service equipment. Now, that's how we provide to transfer and carry the available short circuit current back to the transformer the source, and it returns on the phase that is shorted out at the location where it's shorted out, and we locate that at the location, and then clear the overcurrent device in a systematic order in accordance with 240 240.40 of the code. Now, notice that clearance that we're talking about there is that we would clear the 20 amp overcurrent device in the sub panel. We wouldn't clear the over 200 amp overcurrent device back in the service equipment. So I think I gave you a mask. I didn't quote you right. I said 240.40. No. For having a overcurrent device clear in a systematic order, it's 240.12. So excuse me on that. Look at 240.12 for a systematic clearing of your overcurrent device and localizing your fault. So available fault current is addressed in 110.24a and b, and as the sections I gave you provide the general requirements and general principles to provide a safe equipment grounding path for that fault current to travel over.